This is Algebra 2, set 111. So these are, these are called systems of equations with three variables or three unknowns, three equations. So, and these are number value problems. So you have 26 nickels, dimes, and quarters in all. The value is $2.25. How many of each type of coin are there if there are 10 times as many nickels as quarters? So we're going to start with 26 nickels, dimes, and quarters in all. That is a number problem. So the number of nickels plus the number of dimes plus the number of quarters is 26. Now we'll look at value. So this is where we put in the value. We have 5 for every nickel, 10 for every dime, 25 for every quarter. And because we're multiplying the cents by 100, we're also going to multiply $2.25 by 100 to get 225. So there's two equations for us, and now we need our third equation. The third equation says there are 10 times as many nickels as quarters. So remember, when you're thinking about this, that means there are a lot more nickels than there are quarters, so you have to multiply quarters by 10 to get the number of nickels. So 10 times the quarters is equal to the nickels. So now we have three equations. The bottom one is really easy because it's a substitution. So we have an n, so we can go and plug it in where there are other n's. So we do that. We plug 10q in. We get 10q plus d plus q is 26. If we simplify that, 11q plus d is 26. Then we can plug it into the other equation. 5 times 10q plus 10d plus 25q is 225. Work that out. You get 50q plus 10d plus 25q is 225. And then 50 and 25 makes 75. So 75q plus 10d equals 225. Careful with your d's because mine looks like a 0. Okay, now I have two equations. I have this 75q plus 10d is 225, and I have 11q minus d is 26. I have two equations that I'm going to use systems to solve, or use elimination to solve, so I'm going to multiply the one on the left by negative 10. When I do that, I get negative 110q minus 10d equals negative 260, and then I can add those, and when I add them, negative 35q equals negative 35, so q is 1. So now I take that q and I can plug it into that third equation, or I guess I plugged it into that one. So q is 1, so 11 plus d is 26, so therefore d is 15. Probably would have been easier to plug it in right here, but I didn't do that, but you probably did. Okay, so now I have d and I have q, so all I have to do is plug them in again. I plugged them into that very first equation. So n plus 15 plus 1 is 26, therefore n is 10. So nickels, 10 nickels, 15 dimes, 1 quarter. Okay, here's your next problem. The total number of blues, greens, and yellows was 7. Blues weighed 1 pound each, greens were 4 pounds, and yellows were 5 pounds each. The total weight was 25 pounds. How many of each color were there if there was one more yellow than green? So again, we have a number, a value, and then a third equation. So our first one is going to just be blues plus greens plus yellows is 7. Your second one is going to be blues are worth 1, greens are worth 4, yellows are worth 5, and then it's 25 total pounds. And then the third piece is greens plus 1 is yellow. There's one more yellow than greens, so we have to add 1 to green to make it equal yellow. So this is another substitution problem where I can just substitute for y. So I get b plus g plus 1 is 7, or in other words, b plus 2g is 6. Then in the second equation, b plus 4g plus 5 times the quantity g plus 1 equals 25. Simplifying that, we get b plus 4g plus 5g plus 5 is 25. simplify that. B plus 9g is 20. So now I have two equations that I can simplify or add together for systems. B plus 9g is 20. B plus 2g is 6. I can just subtract and end up with 7g is 14 and g is 2. Once I know g is 2, I can plug it in to the g plus 1 equation to get yellow is 3. If I know there are 2 greens and 3 yellows and a total of 7, then blue has to be 2. All right.